Okay, students, so we start off with class 12, chapter 1, solutions, and the three terms in the front is molality, and mole fraction. So one by one, I'll be discussing and I'll be explaining with some examples which will actually clarify the doubt. So these are the three very important terms which you'll be learning in your class 12 solutions chapter. The first term is molarity, which is denoted by capital M. What is the molarity states? Molarity states the concentration of solute in solution, volume of solution. What is the volume? 1 liter. So always remember the volume of solution should be in liter. So if the volume of solution is in milliliter, so we convert milliliter to liter by dividing by 1000. Next important term is molality, and this is denoted by small m. So what is molarity is number of solute or concentration of solute in mass of solvent, that is in kg, that should be in kg. So if it is in gram, then you have to divide by 1000. In molarity, it is the SI unit is mole per liter, and in molarity the SI unit is mole per kg. Next is mole fraction, which is denoted by small x. Now, mole fraction of XA or mole fraction of A is N symbolizes number of moles of solute A divided by number of moles of solute A plus solvent B. A is solute and B is solvent. So total solute plus solvent should be at the denominator, and whatever we are finding should be in the numerator, and everything will be number of moles. Mole fraction of B, that is solvent, is equal to number of moles of solvent divided by total number of moles of solvent and solute. XA, that is mole fraction of solute plus mole fraction of solvent, will be always equal to 1. Now after writing this, let us discuss about the terminology number of moles of solute. How to get this term number of moles of solute? What does this number of moles of solute means? So number of moles of solute equal to given mass of solute by molecular weight of solute. So given mass, sometimes the mass of the solute is given and you have to find the number of moles. Suppose 10 grams of water is given, so find out the number of moles. So 10 grams is a given mass, 10 divided by molecular weight of H2O. How to find the molecular weight? H2O molecular weight is 1 into 2. Where does 1 come from? 1 is the weight of 1 atom of hydrogen. 1 into 2 plus the mass of oxygen is 16. So 2 plus 16 equal to 18. So number of moles of water N equal to 10 by 18. After the concept have been cleared, let us move on to some numericals. So question number 1 states that calculate the molarity of each of the following. Solution A, 30 gram of, this is cobalt nitrate, CONO3 2.6H2O. 6H2O means 6 molecules of water helps to crystalline in 4.3 liters of solution. So here the solution is in liter. And what does B says? 30 milliliter of 0.5 molarity of H2SO4 diluted to 500 milliliter. Let us do one by one the question. Capital M stands for molarity. Molarity, the formula is number of moles of solute. Here the solute is cobalt nitrate. Crystallization of cobalt nitrate by volume of solution, that is in liter. So first we have to find out what the number of moles. Here the given mass of solute has been given, that is 30 grams. So we need to find out the molecular weight of cobalt nitrate. Here the cobalt atomic weight is 59. So CO 59 plus within bracket is nitrogen and oxygen into 3. Nitrogen is 14 plus oxygen is 16 into 3. And what I have to multiply, this entire time will be multiplied by the term 2. So 2 into 14 plus 6 into 3 plus 6 should be multiplied by with the molecular weight of water. What is the molecular weight of water? 1 into 2 plus 16. That is 6 into 18. So 59 plus 124, when we solve it, we get 124 plus 108. It comes to gram, that is 291 gram. What is this? This is molecular weight of cobalt nitrate. So now we have got given mass by molecular mass or molecular weight. So by dividing, we will be getting what? We will getting number of moles of cobalt nitrate. Let's do it. So here the given mass of cobalt nitrate is 30 gram. And molecular weight, we have just found out that it is 291 gram. So now we can find out the number of moles of solute, that is given mass by molecular weight, that is 30 by 291 mole, which is 0.103 mole. Okay, now we have the number of moles of solute and it's already been given the solution in liters. What is that? That is 4.3 liter. So molarity is number of moles of solute by volume of solution in liter. So 0.103 by 4.3. Now when we have got a fractional decimal, we can remove the decimal sign by moving the decimal sign towards the right. So in the numerator we have got 3 places of decimal sign, so we remove it by moving it 3 places. So jump 1, jump 2, jump 3, so 103. So I have jumped the decimal point 3 places towards the right. At the same time, I'll jump the denominator decimal sign 3 places towards right. So it's 4.3, already 1 place is there. So I'll jump it 2 times. So now what is the value? The value is 103 by 4300. So when we divide, we get the answer as 0.023 moles per liter. This is mole, this is liter. So moles per liter. You can also write as mole liter to the power of -1. So either way it is correct. Let's do the part B. So what is the second part of the question? Says 30 milliliter of 0.5 molarity of H2SO4 diluted to 500 milliliter. So let us understand with the help of diagram. We have 2 beakers. First beaker have a solution of H2SO4 where M1 molarity is 0.5 and volume, that is V1, is 30 milliliter. It has been diluted to another beaker and the volume now becomes 500. So 30 becomes 500. What is the change in molarity? 0.5 will become what? So we will use the dilution formula. What does this dilution formula says? M1 V1 equal to M2 V2. Now we place the numbers. M1 means 0.5 into 30 equal to M2 into 500. So M2, I'll bring 500 to other side of the equal to, and it is multiplication, so it will be divided. So 0.5 into 30 divided by 500. So 0.5 will be fractionized to 5 by 10. Why? Because 0.5 number of places of decimal, number of places after decimal is 1. So 5 by 10 into 30, 0 0 cut, and in the denominator it is 500. So 5 is 15 by 500, 5 is 15 by 100, so 3 by 100. So 3 by 100, can I put the fraction in decimal? Yes, of course. We'll place 3 times decimal point to 2 times decimal point from the right to left. Let us do it. So always remember, a number without a decimal point means the decimal point is always lying on towards the right side. Divide by 100 means there are 2 zeros, so we have to jump the decimal from right to left. So I have jumped first position jump, and then second position the decimal point lies here, and there is 0. So what is the answer? 0.03 molarity. Okay, let's proceed to the next question. So question number 2, calculate the mass of urea. There's a formula of urea, NH2CO NH2, required in making 2.5 kilogram of 0.25 molar aqueous solution. So 0.25 molar aqueous means water, solution. So reading this question, we have found out that aqueous solution, urea is mixed in the solution, so urea is solute and water is solvent. Now next is molar small m equal to number of moles of solute by mass of solvent in kg. So what is this? 0.25. So 0.25 molar means 0.25 moles of urea present in 1 kg of water. Okay. So let us find out the molecular weight of urea. So now if I write this sentence, we have found out that 0.25 moles of urea. So this number of moles of urea is 0.25. Let us find out the molecular weight of urea. Molecular weight of urea, so NH2CO NH2, N is 14, H is 1, C is 12, O is 16. So 14 plus 2 into 1 plus 12 plus 16 plus 14 plus 1 into 2. If you calculate, you will get 60. 60 gram. This is the molecular weight. Molecular weight of urea. Now using the formula, number of moles of urea equal to given mass by molecular weight. Number of moles of urea is 0.25 equal to given mass. Given mass we have to find out, and we have just found out the molecular weight. So given mass by 60. So given mass of urea is, the 60 goes from division to multiplication, so 0.252 into 60, which is 15 gram. So now we have found out the given mass of urea. That is the given mass of urea. Okay. So after getting the urea mass, given mass of urea, that is 15 gram, now we find out the total mass of solution. Why total mass of solution? Because we need to do a unitary method, because we need to find out the mass of urea in or diluted in what? 2.5 kilogram of the solution. So let us do it. Total mass of solution is 1000 kilogram of water plus 15 gram of urea. So total gram is 1015 gram. Convert gram to kilogram, divide by 1000, and we shift the decimal from the extreme right to left. How many times? 3 times. Jumped 3 times. So 1.015 kg. Now we do simple unitary method. 1.015 kg of solution will contain 15 gram of urea. Now, as per the question, 2.5 kilogram of solution will contain 15 divided by 1.015 into 2.5. Okay. So we multiply 15 into 25. 15 into 25, 5, 7, 5, 15 into 5 is 75. And 15 to 30 plus 7, 375. And we shift the decimal point from right to left. So 37.5 divided by 1.015. So 37.5 and 1.015, the decimal point. So now we shift the decimal point towards the right. Here I am shifting because denominator is bigger. So the decimal point of denominator is bigger. So point, if I want to remove the point from the this denominator, how many shifts? 3 shifts. 1 shift, 2 shift, 3 shift. So here also I will be shifting. So I'll putting zeros when I don't have numbers. So what is the number? 37500 divided by 1015. I cut these numbers with 5. 5 goes in 10 root times 0, 5 is 15. So denominator is 203. Here 5 is 35. Balance 2, 25, 5 is 25, 0. So 7500 divided by 203. So if you keep the answer at this order, you will get full marks, or you can divide and get 36.94 gram. What is this? This is the amount of urea present in 2.5 kilogram of aqueous solution. Let's move on to another question, question number 3. So next question is calculate A molality, B molarity and 3 mole fraction of Ki. What is Ki? Potassium iodide. K is potassium, I is iodide. If the density of 20% mass per mass aqueous Ki is 1.202 grams per milliliter. Okay. So we have to find the molarity. And what has been given? 20%. 20%. Now, 20% when we have 20 percentage, we assume the solution to be 100. So let the total solution present be 100 gram. So 20% of Ki means 20 gram of Ki present in 100 gram of solution. Is what percentage converted now to gram. Okay. So mass of solute, that is Ki, is 20 gram. Solvent is 80 gram. What is solvent? Aqueous, H2O. And solution, we have assumed it as 100. Okay, now we have to find molality. What is molality? Number of moles of solute by mass of solvent in kg. So first we have the given mass, but we have to find the molecular mass of Ki. So molecular mass of Ki, K is 39 and I is 127. So we add up 139 plus 127 is 166 gram. So what is this 166 gram? This is the molecular weight of Ki. So 20 gram is the given mass, molecular weight is 166. So we divide to get the number of moles of solute. So 20 by 166 we divide by 2, 2 8 is 16, 2 3 is 6, 2 1 is 2 and 0. So 10 by 83, 10 by 83 is 0.120 mole. So now we have got the molecular, so now we have the number of moles of solute, that is 0.120 mole. Okay. So what, summing up, what we have got, mass of solute is 20 gram, solvent is 80 gram. 80 gram means 80 by 100,000 kilogram. So 80 by 1000 means you have to shift the decimal point 3 times. So 0.080 kilogram. Why kilogram? Because in molal we have to have the denominator divided by mass of solvent, that is in kg. And we already found out that the number of moles of solute is 0.120 mole. Now we put number of moles by mass of solvent, number of moles by mass of solvent kg. So 0.120 divided by 0.080. We move the decimal 3 place to remove the decimal. So what we're having is 120 by 80. 0 cancelled, and we can divide easily by 4. 4 2s are 8, 4 3s are 12. So 3 by 2, 3 by 2 is 1.5 molar. So this brings the end of part 1A of the answer. Let us go to molarity. So part B says we have to find the molarity. Molarity, the formula is number of moles of solute by volume of solution in liters. Number of moles of solute we have already found out, 0.120 mole. Okay. We have already got mass of solution assumed as 100 gram. And from the question, the density have been given. What is density? 1.202. What is density? Density is mass by volume. So density equal to mass by volume, and density have been given as 1.202. Mass of the solution have been given by as 100 gram. So we need to find the volume. But caution, volume is in milliliter. Okay. So volume, if I put or I bring the volume on the other side of the equal to side, what will happen to this number? This number will go to the denominator. So volume will be 100 by 1.202. I shift the denominator decimal 3 places towards the right. In that order, I will be adding 3 zeros. So what will be the result? 100 plus 30 divided by 1202. Why I have done this? This I have done to remove the decimal. But this is in milliliter. In molarity, we have to get the new denominator as in kg, mass of the solution as in kg. So we have to convert milliliter to liter. So when we convert this to liter, we divide by 1000. So this denominator will also add up 1000. Let us do it. So I divide by 1000 to get into kg. And on doing so, see 3 zeros and 3 zeros cut. 100 by 1202 divide by 2. 2 6 are 12, 0 2 1 are 2, so denominator becomes 601. Numerator 2 5 are 10, 0. So 50 by 601, that is in kg. If I divide, it is 0.083 kg. Very simple now. Molarity, we have already found the number of moles of solute, that is 0.120. Mass of solution in kg, 0.083. Divide, we shift decimal place 3 places on the right. So 120 by 83, 120 by 83 we cannot cut, we have to divide. It becomes 141.44 moles per liter or molar. So you can either write moles per liter or you can write molar. Okay, now let us do part C of this question. So part C says mole fraction of potassium iodide. So mole fraction, the formula is molecular number of moles of Ki by total number of moles of solute and solvent, total number of moles of Ki plus number of moles of water. The number of moles of water is not, we have not found out. So let us find out. Molecular weight of water is 18. So number of moles of water is given mass by molecular weight, that is 80. That is what the solvent is, 80 by 18. We divide by 2, 2 9s 18, 2 4s 8, 0, 40 by 9, 40 by 9 is 4.44. So now we put it in the formula. Mole fraction of Ki equal to number of moles of Ki, that is 0.120 divided by total number of moles of solute and solvent, that is 0.120 plus 4.44. So 0.120 divide by 4.450. Shift the decimal right side 3 places. So 120 divided by 4450. 0 and 0 cut. We have to do the normal long division and we get the answer as 0.0263. This is the answer of the mole fraction. So this brings end to the section solution of the chapter 1. I hope you have liked it. Please do subscribe my channel and send it to your friends so that everybody can be benefited. Thank you so much.